All right, here we go. As promised, rectangles. All right, so one or the major property of a rectangle, right, is the fact that the diagonals are congruent. Now, first, let's talk about what a rectangle is. So a rectangle is a parallelogram, or it's a quadrilateral, basically, but it has four right angles. Four right angles, or four congruent angles, right, which would make them all right angles. So now, if you know that it's a rectangle, you now know that the diagonals are congruent, right? So unlike a parallelogram that's slanted, right, and those diagonals are not congruent, because a rectangle is upright, right, right angles, those diagonals now become congruent, right? It's very hard to mark that on a picture. Okay. Now, the one thing I do want to talk about is that because it is a parallelogram, right, so in a parallelogram, the diagonals do bisect each other. So if the diagonals do bisect each other, and in a rectangle the diagonals are congruent, right, then each, I'm going to use 3 dashes, each of these smaller parts is going to be congruent to the other, right? So typically in a parallelogram, the 2 on AC would be congruent, the 2 on BD would be congruent because they're bisected. But now, because we know the diagonals are congruent, all 4 of those smaller segments are congruent. So if you see 13 is equal to 13, I'm going to go to Savas. Let's explore this a little bit. Okay, so again, we can move the corners. There you go, right? Right, no matter what shape the rectangle is in, those diagonals can be congruent. Okay, so let's prove this theorem, huh? We haven't done a proof in a while. All right, let's have some fun. Here we go. So we want to prove that if a parallelogram is a rectangle, that the diagonals are congruent, right? So here is our proof. Sorry for this word proof. So we are given that PQRS is a rectangle. We want to prove that PR is congruent to QS. And we cannot use this theorem because we're trying to prove it, right? So if I'm looking here, right, notice that this rectangle is broken into 4 triangles. However, it's not 2 of those 4 triangles we're going to use. We're going to use a pair of overlapping triangles just because of where PR is. PR is here. And where QS is. QS is here. We're actually going to use these 2 right triangles. And I'm going to actually go back and erase. Let me make the first right triangle in red. I'm going to use triangle PRS. Right? And then I'm going to use triangle, so PRS, QSR. Right? I know that because these things overlap and because there's right angles involved, I know that I can prove these 2 triangles congruent, and then PR and QS are corresponding parts of those congruent triangles. So I'm actually going to draw the triangles separate. So here's the one. So P, R, S. And again, it's in blue, so I guess I'll continue that on. Sorry about the kind of quick, terrible drawing. In Q, S, R. Right? Okay. So I always start with the given, right? So number 1, so PQRS is a rectangle, right? That was given to me. So based off of a rectangle, right, I know that I have 4 right angles. The 2 that I want to talk about are angle S and angle R. We're going to use 3 letters though, so I know that angle PSR and angle QRS are right angles. And that is the definition of a rectangle. Rectangle has 4 right angles. Definition of rectangle. So now PR and QS are the hypotenuses of those rectangles. If I want to prove them congruent, I cannot use them. So I'm not going to use HL here. So because I'm not going to use HL to prove these triangles congruent, I am going to say that these 2 angles are congruent. So angle PSR is congruent to angle QRS. And that is the fact that all right angles are congruent. All right angles are congruent. And there's a pair of angles. So there's an A. Right? Okay, now this is a parallelogram, right? If it's a rectangle, it's a parallelogram. We know that opposite sides of a parallelogram are congruent. We have a pair of opposite sides in this rectangle, PS and QR. PS and QR are opposite sides. They're going to be congruent. They're here and here in my big picture. So I know that segment PS is congruent to segment QR, And that is because opposite sides of parallelogram are congruent. And that is a pair of sides. There's the angle pair. Okay, so I'm well on my way. I have 2 out of 3 pieces I need. Where's the last piece going to come from? Well, because these 2 triangles overlap, they both share SR. SR is congruent to itself. That's the reflexive property. So segment SR is congruent to segment SR. That is by the reflexive property. And I'm going to finish my proof off to the left here. So again, now that I have those sides marked congruent, you can tell that these 2 triangles are congruent by side angle side. So my 6th step, I'm going to say that triangle PRS is congruent to triangle QRS. I'm sorry, PSR. Sorry. Correspondence is important. Triangle PSR is congruent to QRS, PSR, QRS. That is by side angle side congruence. So then if those 2 triangles are congruent, then all of the corresponding parts are congruent. Segment PR and QS are a pair of corresponding parts. So they are going to be congruent by CP, CTC. And there we go. So again, can't ever do too many proofs. But now you should believe, always and forever, that the diagonals of a rectangle are congruent. Alright, so let's take a look at 2 more problems here, and then this video is done. Alright, so it says, Paul is training his horse to run the course at a pace of 4 meters per second or faster. Paul rides his horse from D to C to E to B in 1 minute 30 seconds. The figure ABCD is a rectangle. Did he make his goal? Okay, so here is the fact that it's a rectangle, right? So I know that I have 4 right angles at A, D, C, and B. Okay. I also know that if my path is from D, so D to C to E to B, right? If that's my path, I know that this bottom side is also 192 because opposite sides are congruent because it's a parallelogram. And I also know that because the diagonals bisect each other and are congruent, that these 2 pieces are the same. Right? So I think what I can do here is I can actually use Pythagorean Theorem. Right? If I take a look at one of these triangles, and I don't care which one, I'm going to do this one, ADC. Right? These 2 pieces here would make AC, right? Because this is also congruent. So if I can find the length of AC, that's going to be EC and EB together as well. So I'm going to use Pythagorean Theorem. Here's my picture of my right triangle. Again, A, D, C. I know this is 80. I know this is 192. I want to find this. Okay? So Pythagorean Theorem says that A squared plus B squared equals C squared. X is my C. A and B don't matter. So 80 squared plus 192 squared equals X squared. Type in 80 squared plus 192 squared all at once. 43264 equals X squared. And we're going to take the square root of that number. And would you believe that that is a perfect square? I would never have believed, right? And our value of X is 208. That is EC plus EB. Right? Again, the last 2 parts of this path. And that is again because the diagonals are congruent and they bisect each other. So I'll put that over here. The diagonals are congruent and they bisect. Okay, so then what is my total path? So my total distance is, well, I started at D and went to C, 192 plus, and then C to E and E to B is this 208 plus 208. 192 plus 208 is 400. I want a distance of 400 meters on this picture. I want to see if I'm at a pace of 4 meters per second or faster. So I'm going to change colors here. the time they gave me, so my time is 1 minute 30 seconds. Right? We need to know that a minute is 60 seconds. So this minute is 60 seconds plus 30 seconds, so our time is 90 seconds. So to figure out our pace, right, we're going to take our distance, 400, and divide it by 90. So to find our pace, we're going to do the 400 meters divided by the 90 seconds. Okay, when you take 400 divided by 90, you do get 4.4 repeated, and that'd be meters per second. So he wants to know if he ran the race, or if his pace was 4 meters per second or faster. That would actually mean 4 meters per second or less. Oh, I'm sorry, I'm wrong. No, he's good, right? Because he's covering more ground per second than 4, right? 4 meters per second or faster. So if he's higher than 4, that's fine. I apologize for mixing that up. So this is good. Because he's at least 4 meters, he's more than 4 meters per second, he did meet his goal. So Paul met his goal. And again, his pace was 4.4 meters per second. Okay. And then last but not least, let's talk about a square, I think, okay? So a square, okay, is the marriage between a rhombus and a rectangle, because a square has the property of a rhombus that it is 4 congruent sides. So 1, 2, 3, 4. It has the property of a rectangle that has 4 right angles. So angle W, angle X, angle Y, and angle 0 right angles. So that's why this is a square, right? So it has all of these properties. Okay. So it tells us if WY plus XZ is 92, what is the area of the square? So what they're doing here with this WY plus XZ, this is the sum of the diagonals. So the sum of the diagonals. Okay. So first of all, if WY is congruent to XZ because it's a rectangle where the diagonals are congruent, then to find out what each diagonal is, we're just going to take that 92 and divide it in half. And 92 divided by 2 is 40. Oh, no, sorry. 40? Yeah, 46. Yeah. So that is the length of each of those diagonals. So that equals WY, which equals XZ. Right, so that's the first part. So now we have the length of a diagonal. So now what I'm going to do is the following here. Okay, I'm going to focus on triangle WPZ, right? This blue triangle. I'll trace it in purple. So because it is a rhombus, right, we know that the diagonals are perpendicular. And we already talked about the diagonals are congruent, so each of these pieces is congruent because they're also bisecting. So this is congruent to this, is congruent to this, is congruent to this. So because it's a rhombus, I know the diagonals are perpendicular. So to find the area of this triangle, we need to use the formula area equals 1/2 base times height. Because of this right triangle, I know that the 2 parts of the diagonals are the base and height, because in a right triangle, the base and height are the legs. So if each of these diagonals is 46, then each of those parts is going to be 1/2 of 46 because they're each being bisected. So we're going to take 46 and divide it by 2 again. That's 23. And again, that's because the diagonals bisect each other. And that's just the property of a parallelogram. So see all these properties flying around? So this 23 is both the base and the height of that triangle. So 1/2 times 23 times 23. You would multiply all that fun stuff out. it is 264.5, and that would be units squared, whatever the units are. And there's the area of that one little triangle. I could easily find the area of the entire square by multiplying that by 4 if I wanted to. All right, great. So thanks for watching this video on the special parallelograms. Very important stuff. Good luck on the homework.